Yep. Awesome. Cool. All right. So yesterday's homework, if you did it, it was just checking for parallel or perpendicular. Today, we are going to take another trip back through Algebra 1, and we're going to talk about equations of lines. Now, if you have Algebra 2 this year, hopefully this is going to be a crazy easy section, because we've already covered this again in Algebra 2. But math, due to its nature of building itself, you see the same thing year after year. It's just how much time you spend on the old stuff. It starts decreasing. Okay, when we write equations of lines, on the count of 3, if you have an equation in mind, maybe with a y and an equal sign, is my guess, can we all shout it out? 1, 2, no, let me pause. We're going to say y equals, and then we won't even count down. Just go y equals, and then you guys will tell me the first thing that comes to your mind. Because I think I know what it's going to be. It's either nothing or a very specific expression. Everybody ready? 1, 2, 3. Y equals
mx squared. Oh, mx plus b.
What was the one you were saying?
Squared.
So so you're thinking quadratics, that's awesome. But mx plus b sounds familiar to everybody. In the equation mx plus b, what is m?
Slope.
What is b?
Y-intercept.
The y-intercept. So if you just told me it's slope and the intercept, right? So one of these two forms that you guys have seen has exactly that name. Slope, intercept. Now, I'm not going to bless you. I mean, I will because I just did. But I'm not going to go into like crazy detail with this one other than just writing down the formula and maybe a couple things. We will do an example with this, but slope intercept is the one that everybody thinks of all the time. It is exactly that y equals mx plus b. Now, couple little comments. Whether you need to write it or not, remember, it's always your choice. But what is m again? So that's nice to be able to identify. And b is the what? The y-intercept. Now, I'm going to add one more little piece here. I'm not going to write down like the formal definition. When we talk about the y-intercept, on a graph, what is it? Wherever my line crosses the y-axis. Okay, it's where it intercepts with that axis. And the y is this one. Okay, now with this, really important and kind of important, honestly, but really helpful. Y-intercept, we're going to do a little bit more about this piece. If we're at the y-intercept, that ordered pair will always have the same kind of look. And you don't have to sketch this graph, but I want to think about it. Do I have a line right now that has a y-intercept? Yes. Okay. And let's say that this is at, we'll say there's 2. What do you think this is?
3.
So if this is 2, that same distance would be 2, so that should be 4. Everybody okay with that? You don't need it, but check this out. What ordered pair is this then? 0, 4. And we can all see it on the graph when we look at it, but if you don't think about this when you're writing these equations, you're going to make a little bit more work for yourself than is absolutely necessary. So I'm just going to go here and say y-intercept, comma, has form 0, b. It will always have a 0 for the x. If you recognize that every time, it's pretty chill. Okay. Anybody other than Lily, and no offense to you, but it's just because you're in algebra, does anybody know the other form or remember another form? Fifth hour did not really seem to remember it. A couple people did, but not everybody. Instead of slope-intercept, and I'll even write it up here on the board, I'll give you the name, we have another form, and I'm going to switch colors so we can differentiate, known as point slope. Does this one look familiar to you guys? Sort of. Okay. You probably don't remember it. Like you might remember seeing the words, and hopefully the words kind of feel familiar. Anybody feel like they remember the actual equation? Y minus y1, and I'm going to actually do color coding in here. Y minus y1 is equal to m times x minus x1.
I'm gonna time sign.
What's that?
You know how you say times with x before? I've not done that in a long time.
You shouldn't. The second you start, and you're, realistically you can. If you're going to do multiplication, weird emphasis there. But if you're going to do multiplication, I would use the dot or implied parentheses. Like, obvious reason why not to use x, right? Okay, this form looks familiar to you guys or not? Raylene, Ashley, Vincent, Camille, Andrew, Carson? It does not. Okay, so you might not have seen this one, realistically. It's strange if you didn't see it in an Algebra 1 course, but I get it, like we adjust what we teach. Okay, y minus y1 is equal to m times x minus x1, where, and we're going to be a little bit wordy this time, I don't know if I have to say it. What do you think this m is? The slope. Do I have to write it? Okay, the point x1 comma y1, that's our point that we're given, where that point is on the line. Bless you. Okay. Now, naturally, if you're more experienced with this one, you're going to want to use this equation. I get it. We're going to do the same. We're going to do a couple problems with this, and like today's lesson is pretty short. You'll have time in class. I am going to steal a little bit of it to do note card stuff. Did we make a note card together last time?
Yes.
So we won't finish it here, and I'm going to ask that we don't fully finish it, because I want you to add stuff to it based on the team test and where you struggle with things. But we're going to do at least one, probably two problems, but we're going to do it in both of these, because everybody's going to want to do this. I'm going to suggest that we should use this one, like 90% of the time. Okay. Now, let's jump in. Two forms. Now, there is a third form that we're not going to cover in here. It's ax plus by equals c, and eventually we might cover it, but we don't need it today. So here we go. Example. I want us to find equation of line, and we're going to look at two different variations of example, but we're going to do it with both of them for the first one. I want us to find the equation of the line, and on A, let's say, I don't know, we want the line parallel to y equals 3x plus 1. So we have a parallel line, but we also want it to be through. Let's give ourselves the point 2, 4. Okay. Now, you don't have to sketch it, because I don't specifically ask you to, but if you want to be able to make sense of it just to see what we're doing, I have no issue just giving a little sketch. Can we graph 3x plus 1? Because I don't remember how to do it. So you said go up 1. Perfect. On our way to
On the coordinate plane.
So do what?
Go up one. On the graph. Y.
Oh, on the y-axis. Okay. Like, I'm obviously being facetious, but you see the difference. When we say go up 1, if you don't tell me where to start, it doesn't mean anything. What's the y-intercept of that line? Y equals 3x plus 1. 1. Okay, so what Ray is telling me, and I know this is 100% what you meant, he's saying plot this point. There's my y-intercept at the order pair of 0, 1. It's just 0 feet. 1. What's my slope?
3 over 1.
And so, love your answer. Whoever said 3x, I also like that answer, but we don't need the x. It's just the number in front of it. So what's the number in front of x here? 3. Well, you said what? What's the number in front of x? The m.
3.
Okay. You just misspeak with the 1?
Yeah.
Okay. If there's confusion, we should clear it up. Like, I'm not trying to call you out. Sorry if you feel that way. We're in a small class. M is right here, just connected to x always. I see my slope is 3. Now, you might have been mixing up with something Carson said. Carson, you said a different number, but I liked it.
3 over 1.
This is really 3 over 1, right?
Yeah.
Slope is rise over run. That's 3 over 1. If I'm at this point, what's the rise amount?
3.
So 1, 2, 3. And the run amount?
1.
There it is, right? And my scale is a little bit different. That's okay. There's my 1. And here's my line. Okay, everybody cool with that? Now, the problem that we're dealing with right now, and whether you can graph it or not isn't really a huge focus, but if you don't remember how to graph, this nice review here, I'm trying to find a line that goes through this point at 2, 4, right here, that's exactly parallel to it. So whatever the equation of roughly this purple line is, that's what we're after. Now, to do this, we're going to work it out. I assume that you guys want to use this form, is my guess. Okay. Looking at this, to find the equation that's parallel, you guys told me this at the start of class. I'm going to switch colors. We're only finding one line right now. What does the slope have to be if I'm looking for a slope that's parallel? I'm going to use M sub parallel. Is it 3x or just 3? Just the 3. Now, if you say 3x and you use, and there's an issue, and we'll see, because I see on your face that maybe you're thinking I'm being like really nitpicky about it, but I think that the way that we speak is really important, and I'm going to highlight the issue only with you though. Okay. All right. So we got the slope is 3. You guys all want to use y equals mx plus b naturally. So how do I do this? So if we just plug in, it's y equals 3x plus b. Okay, that didn't get me everything.
Aren't parallel slopes the same, but just the b is different?
Yes, so that's how we got 3. I agree with that. But how do we get b? Do you guys agree that right now in this equation we have 3 variables written? I can't solve for 3 unknown things in a single equation. However, I want b in the end. I want to solve for b, which means I want to be able to plug something in for which values? So we want the value of b. Everybody agree with that? So plug in an x and a y, x and y. If only anywhere in this problem we were told when x is this, y is this. Let me make that a question. Were we ever told what x is when y is this, or vice versa? Where? Check it out. We know it runs through the point x is 2, and I'm going to really try to separate this. It runs through the point 2 and 4. Can I rewrite this equation and just plug in x and y? And does this feel like something you remember doing in algebra? Before we kick on, Carson, are you cool with this, or do you have a little apprehension to it? I can't tell. Does it look familiar? You remember doing this? Okay, so let's knock it out. We have 4 equals 3x, and I'm going to go in just a second. We'll put in the x there, plus b. Ashley, Raylene, Vincent, Camille. Does this feel like stuff you did last year? Okay. I'm sure it happened last year, but it might have just been glossed over really fast because quadratics is really the focus of Algebra 1. All right, so help me out. Can we solve this for b?
Yes.
I'm only going to do one color now since I've already done the substitution. I get 4 is equal to 6 plus b. And I'll subtract 6 from both sides of the equal sign. And I now get b is equal to negative 2. Are we done? No, why not?
Now you have to plug it in.
Now we got to re-plug it back in to here, right? We needed to find b. That's what we've just done. So knowing that m is 3 and b is negative 2, I think we can conclude here that y of our new line must be equal to 3x minus 2. I put very little thought and effort into my graph, and I can't even see it clearly. But the second line that I drew, does it look like it could possibly cross at negative 2?
Yes.
Like, I didn't really put a whole lot of thought into it. It's kind of close. It's not perfect. This problem is one way to do it. This is realistically the way that I'm sure you did it last year, whether you remember it or not. Probably the way you did it in 8th grade also. What I want to do is I want to show you a better way.
How'd you get 2 and 4?
We pass through the point 2, 4. Yep. And if you need to in your notes, I would connect these to make sure that they're both there. Okay. So I'm going to go ahead, and I should have done this before. I'm going to say this is all part 1. Because what I really want to do is I want to show you that this other equation, the point slope form that looks gross and awful, is actually the better and easier and faster choice for us. If you're not going to pop, I'd rather wait till after this one. Okay. All right. So right off the bat, we're going to work the exact same problem. I don't have to do everything again. Do we already know what the slope needs to be if it's parallel? What did we say it was?
Same,
It's 3 again. Like, I'm doing the same problem. I'm just going to do it with that point slope instead. Okay. Can we all agree that I don't have to write this again? Or I guess I could. It takes me like 2 seconds. So on 2, we're going to do this problem in point slope form instead. Okay. So right off the bat, just in case, I still know for the same problem that the slope is the same. It better be 3. So just because we're doing the same problem. Now, the point slope form, can you guys still see it on your page? Okay, I appreciate the 16% feedback. Cool, we have it. Let's try to write real quick. What's the ordered pair that we run through? And I'm going to write that again. I know it's right here, but I'm just going to write it again once more. Now all I'm going to do is I'm just going to write that point slope form, which you guys have on your page. It is y minus y1 is equal to m times x minus x sub 1. And it looks ugly. Quick poll. I think you guys probably believe most of the stuff that I say, especially if it relates to math. Anybody believe me that this is really going to be easier and better? Lily does. Raylene, do you believe me? Or do you think that, like, you're just saying he's a math teacher, he thinks it's easy, it's not easy? Okay. Do you really, or are you just saying that 'cause I'm putting you on the spot?
No, I'm just, I do.
Okay, we play the awkward eye contact game in Calc last hour, and it's super fun. Maybe we'll play it here today. You guys remember the awkward eye contact game? Yeah, cool. We'll play it here in a minute. All right, here's where I'm at. And I'm going to make a note, because if you've never done this, there's some easy mistakes to make. We only ever plug in numbers or values, if you'd rather, for x1 and y1. Now, I don't want you to confuse it when you write it down. I'm going to add another comment in blue. Entirely up to you if you can write it clearly. Not x and y. And really important here, can you tell me the difference that I'm trying to really highlight? Am I ever going to replace this thing in my equation? Never. Never, never. I'm always going to keep it y. I will replace the y1. I will never replace the x. I will only replace the x1. And the m, we're going to put it in because I already have the slope. Never touch just x or just y. You can touch x1 and y1. Now, let's keep rolling with it. Help me plug stuff in. Y minus, what is that y1 value that we run through? 4. Y minus 4 is equal to my slope we've already decided, parallel, is 3. And we're going to have x minus some other number. If only there was an x that I knew was on this graph. 2. Okay. We're almost done already. Like, legitimately almost done. I'm going to do 2 lines of work with the understanding that you might do 1. What happens? What's the algebra asking me to do right here? So I will distribute. And I'm going to draw my distribution lines. Camille, when I distribute the first term, what do I get? Minus, Vincent, what's the second term I get when I distribute? If you weren't looking, here's my second term I'm distributing. Good. Okay, we're 1 step away. Last thing, Andrew, if I want to solve this for y, what would you do? I want only y on the left side.
You do 3x minus 6.
So how do I get rid of this minus 4 is
Oh.
the same question.
Add 4 on each side.
Good. I wind up with y equals 3x minus 2. Do we get the same thing? Now, realistically, I don't know if I'd necessarily say one is easier than the other, but I am immediately going to change my mind. I think that this one's 100% easier. Because in this one, you have to first write it out, then you have to find b, and then you have to come back and remember that it has to get plugged in somewhere up here, and there's places to get lost. Did we ever have to remember anything or plug anything in, or did everything just spit out for me? they're doing the same thing. This is a much more streamlined process. It's one thing. Just plug it in and work through it. The only time, legitimately, the only time that I would ever default to using slope-intercept is if the point that I gave you was 0, something. In that situation, and only in that situation, would I ever bother to just use mx plus b, because the b is already given to me. Okay. Feels all right? Feels terrible. Cool. All right. Last one. Example. I want you guys to work with one another. I'm going to give you a head start on it. I'm going to say that for this, line L, yeah, now you're good, is given by, and I'm going to write y sub L just to keep stuff straight. Y sub L is the equation negative 3x plus 2. Okay, what I want us to do is to find a new line. We're going to find a new line. And what should we name this new line? There's not a right or a wrong. It just can't be L.
All letters?
Yep. Z. Okay, we're going to find a new line Z through, let's say we're going to make this run through the point, I don't know, 3, 1. That is perpendicular to L. That's it. Now, I'm not telling you, and I never will tell you unless there's a very specific situation that I want you to use point slope or slope intercept. I think you should use point slope, but realistically either one works. I want you guys to start working this. Make me earn the money that I'm getting paid right now by asking questions, things like that. Cool. I'll give you a second or a minute. Right off the bat, the most common mistake is right here. We just did a problem a moment ago that was fundamentally different, right? We did one that was parallel. If you make a mistake on this, it's going to happen right here, right now. What is the perpendicular slope and how do we get it? Why? Cool. Yep, I'm always going to whoa with it, just so you know. So this slope, do we all agree, is negative 3 over 1? Flip it and change the sign. Negative 3 over 1 becomes 1/3. Sorry, negative 1/3, and now we change the sign. I think the slope should be 1/3 this time.
Yep.
Okay. Now, with this, we also, get that it's through the point 3, 1. Fine and dandy. I'm good with that. With just this information, whether you use point slope or slope intercept, it doesn't really matter. It's much faster if you use point slope. I'm going to use point slope. And let's just help me plug in. Y minus, what do I need to subtract from this, Camille? Y minus, what's Y1 in this case? Good? Is equal to 1/3 times x minus what, Raylene? 3. Love it. Okay, here's a weird part. If all I ask you for is find a new line, and I'm saying find an equation without saying it, do we have an equation right now? You could stop here. Now, nobody typically does because you all want y equals mx plus b. It's easier to graph in that form. If you stop here, I will not count you wrong, just so you know. But everybody naturally wants to do the next step. So help me clean this up. What's this value? So y minus 1 is 1/3 x. And this value?
Negative 1.
Minus 1. And I'll add 1 to each side. And it looks like my equation is just 1/3 x. And we're done. As long as you pick perpendicular or parallel, or like whichever one, if you use the right formula or the right theorem, the rest of the problem's identical. Okay, last thing that I want to talk about, we don't have to do this problem, and there's very few times, I hope, where it's just me saying, hey, look at me do a problem, but I do want to consider something. If we wanted to find the equation of the line, hypothetically, through, and we can just talk about this one. Let's say I went through 2, 5, and I don't know, 3, or we'll even make it grosser, 12, 11. Could we find the slope?
Yes.
Okay, so if I found the slope, it would be 11 minus 5 is 6, over 12 minus 2 is 10 to be 6/10. Everybody okay with that? Now, you could keep it as 6/10, but it's going to drive me crazy. Does it simplify? 3/5. So the slope is 6/10 or 3/5. When I go to find this equation, I'm going to write down my y minus y1 stuff and my x minus x1. Like, I'm going to fill it down. I'm just going to leave it blank. My equation, if I'm using point slope, is y minus something equals slope m and x minus something. Does it matter which of these points I use? Not even a little bit. Both of those points are on the line. Is there a point that makes more sense to use? Or which one would you guys use? If I said you can either plug in 5 and 2, or if you'd rather, you could plug in 11 and 12. Which one do you think everyone's going to choose? Why? I would pick this point with the smaller numbers, typically. Okay, you don't really have to pick either independently. Like, if you want to use this one, good, do it. You're going to get the exact same answer. But I wanted to make sure everybody knows, doesn't matter which point you use. Cool. All right, that is the end of our chapter. But I will put the problems up on the board. Actually, I'll just grab your book. Cool. Tomorrow I will collect it. Tomorrow we will do the practice test in class. Monday, then we will go over the practice test. I'll help refine and clean up our note cards. Our test looks like it is next Tuesday.
It's still the same page we're starting with?
It is still the same page.